Check, check, check. We've got levels here. We're good. I feel like such a dork wearing a little Bluetooth headset, though, but that's all right. So, remainder theorem. Before we get into this, I actually want to do a quick recall review here of division of polynomials. All right, so let's do some division. If I've got the following, let's say I'm dividing x cubed plus 2x squared minus 7x plus 1, and I'm dividing this polynomial by, let's say, I guess I'll make this one easy, x plus 2, let's say. So, tell me your thoughts. How would we want to try to divide that? Synthetic division would work? Is that the only way that would work? We also have long division. Could someone summarize what the benefits of long division are compared to synthetic division? Does anyone know? What if this was a 7x plus 2? Which method would you rather use? Long division, right? Or what if this was like an x squared plus 7x plus 2? What would you want to use? Long division, right? Long division's strength is that it works for all of the problems. Synthetic division is faster, but it only works in a special case. What do I have to divide by in order to have synthetic division apply? Right. I have to divide by a linear binomial, right? So the first term has to be just an x term. It can't be like an x cubed, right? And there has to be two terms here. And preferably, like she said, the leading coefficient of that linear is 1. If it was a 7 there, we could deal with that. How would we deal with that? Do you guys remember? Divide everything, literally everything, so not just these two terms, but also these all those 4 terms there by 7. But this is an optimal situation for synthetic division. So what would that look like if I synthetically divide? How would I set that up? Aha, good call. -2, so it's the opposite of this number there, right? Opposite, right? And then what do I do? Let's see, I'll draw this line here, arbitrarily it seems.
Put the coefficients of your numbers in the parentheses.
Right, and can I do them in any order? Could I have like 2, 1, -7, 1?
No, you have to do it in order.
Yeah, I have to do it in standard form, right? And what if I was missing a term, so to speak? Then what would I have to do?
You need a placeholder.
Right, a placeholder is 0 there. So yeah, we are all awesome at this now. This is good stuff. So 1, 2, -7, a 1, like so. What do I do to synthetically divide this?
You bring down 1.
Yep.
And then you multiply. Add.
It doesn't look like this one's going to come out to a number that we like, but that's okay. Let's see, that's 14, and that is 15. So I guess my answer is 10,000 -715. What's that mean?
You have to put the x's back in, but 1 less than the first.
Wow, you guys are so masters at this. So because this was x cubed and I was dividing by a linear term, these will also be x terms except 1 degree less than that. So this is 1x squared plus 0 x's, which I guess I don't have to write that. And then -7 would be my linear term. And what about this 15 here? So I could say remainder of 15 or something like that. Or what's the other way I could represent that?
15 were plus 2.
Yeah. So that's the other way. Right? Or you could say remainder 15. And today we're going to be interested in the remainder 15 thing. Let's see. For fun, what would this look like if I long divided it? So I guess let me summarize this. I might as well label that this was synthetic. Synthetic. And then let's long divide this. And let's see, I might need you guys to help me with some of the vocabulary. See if we remember how to do this. Let's see. So I'll have division bar. I always am tempted to make a square root bar, so don't do that. So what goes on the outside here?
X plus 2.
Yep. X plus 2, and then on the inside. And I would also need placeholders if they were to be present, right? If they were required. And so let's see. In terms of vocabulary, you guys know what the name of the inside of this division bar is?
I don't know which one's which, but one of them's the dividend, right?
Yep, this one is the dividend, which I mixed those two up as well. But the way I was just thinking of remembering it was, well, maybe this isn't that helpful, but I remember that the inside of a radical is called radicand. So I figured the inside of a division symbol should also end in an ND. Actually, it ends in an end, oddly enough. Classic. But yeah, so the dividend, kind of like if this was a square root, it would be radicand, ending in the ND. So now that we are certain of that, what would this one be called? Yep, that's the divisor. And then my answer is going to end up being up here. Does anyone know what the answer is going to be called? And then I might have a little scrap hanging out down here. Does anyone know what that would be called? The remainder. Good. So we'll know what all of those terms are called. Yeah, I'm easily mixed up on the dividend and divisor thing myself. So let's see. So let's long divide this. Does anyone know the name of the steps for long division, or the sequence of steps that are repeated?
Isn't it PEMDAS backwards? No, never mind.
Nope, that's for solving an equation. All right, you caught me off guard there. But what is the what are the steps? Does anyone remember? Little 4-letter acronym. No, that would be if I'm multiplying two binomials. Let's see, so D for divide, M for multiply, subtract, bring down, and then repeat. Similarly to synthetic division, the steps would have been add, multiply, and repeat, right? So I added the first column, then I multiplied, then I added, then I multiplied, right? So divide, multiply, subtract, bring down is the sequence of steps here. So let's do that. So when I divide x cubed by this. Ugh, how do I do that? Does anyone remember? Yeah, I divide the leading term by the leading term. So I'm ignoring the plus 2 thing. And x cubed, I might write some little scrap work over on the side, divided by x is x squared. Where should I write that answer?
About x squared.
You guys are professionals. Put me out of my job next year teaching Math 3 instead of me. So let's see. And now I'm on the multiply step, right, because I just divided. And here I will include that plus 2. So I'm going to distribute here and write my two answers there and there. So x squared times x is x cubed because we wanted it to be. That's what we knew had to happen. And x squared times positive 2 is plus 2x squared. So let's see, that was divide and multiply. Now we're on the subtract step. So I'm subtracting this whole row here from the row above it. If you want, you could kind of put a minus sign and then parentheses just so you remember that all of those signs will change, and then you could add, or you could just remember to subtract. It's up to you. So x cubed minus x cubed is 0x cubed. 2x squared minus 2x squared is 0x squared. So this one actually ends up having 0, oddly enough. Bring down the negative 7x. All right, so this is kind of weird. I technically could kind of skip a step here, but I'm going to be super, how should I say, particular in following the order, just so we don't get confused. So my new leading term is technically this 0x squared, and I've just brought down, so I've finished the full cycle, so I'm repeating it over again, divide. What is 0x squared divided by x? Does anyone know? Well, if I was thinking about the x's, right, I would get an x, and then it'd be 0x, and that's just 0. So I could write a 0x here if you wanted the placeholder, but we don't need it. All right. And let's see, 0x times x. And actually, I just want to point out, notice that is in agreement with what we had earlier, that 0 there, right, that 1 there, right, 1, 0. Right, so it is seeming to work out so far. So let's see, multiply 0x times x is 0x squared. 0x times 2 is plus 0x. Subtract negative 7x minus 0x is still negative 7x. And then bring down the 1. Bring it around town. So, now I'm back on divide, and I just want to point out I could have skipped that divide step where I could have just immediately gone to this and said divide negative 7x by x, and I would have gotten a constant term as my answer. And I could have skipped that whole cycle if I wanted to, but you don't have to. So let's see. So negative 7x divided by x, what do I get? Better yet, negative 7. And I'm going to write that in my constants column. And then multiply, I'll get negative 7x. And negative 7 times 2 is negative 14, right? And let's see the subtract step. We technically could cheat since we already did the work on a previous example. But what do you suspect this is going to be? Right, because 1 minus a negative 14 becomes plus 14, which is positive 15. And that is the remainder that I was talking about. Right. So, yeah, that's not that bad. Now, I want us to do a very particular problem here. So that we just recalled 2 skills that are going to be helpful today. We're primarily going to be doing synthetic division once we get moved on a little bit. But I want you to do an example, and it's going to seem similar to this intentionally. But what if I have the polynomial p of x equals, and let's just say it is that polynomial up there, the x cubed plus 2x squared minus 7x plus 1. All right, so there's my polynomial. And I want you to figure out what is p of negative 2. So see if you could do that for me. So take a moment. So I'm going to take a little walk around, see how we're setting this up. So we're plugging in negative 2 for all of the x's using parentheses because we are careful. Right? It's Indiana Jones when he replaced the golden idol with a bag of sand. He didn't just throw sand on a little pedestal. Had it nicely contained in a safe little pouch. I think this is all non-calculator math here. Let's see what we got. So negative 2 cubed plus 2 times negative 2 squared minus 7 times negative 2 plus a 1. What's negative 2 cubed?
8.
No.
Yeah, negative 8. Negative raised to an odd maintains its negativity. Negative 2 all squared is 4. Negative 7 times negative 2 is positive 14. And I get negative 8 plus 15. And I guess you could think of these as canceling each other out, right? And I get 15. Does anyone have any interesting thoughts? I mean, so far this is one arbitrary example that we've done. So it wouldn't make sense for you to necessarily jump to a conclusion off of something that would appear to be a coincidence. But I suppose we could establish a pattern by doing more examples until it seemed obvious that we were confident. And we could perhaps even come to the conclusion and justify and prove our hypothesis. But does anyone have a hypothesis as to how this problem relates to the other problems?
We took the opposite of what we did in the synthetic. We used the opposite.
Yeah?
And used that in the P of X thing. And then we got the remainder.
Yeah. The answer I got was the remainder from synthetic division or long division, right? And it kind of was the opposite thing, right? So if you had a guess, maybe we could do that. Yeah, let's do that. What if I want to figure out what is P of 3 equal to? Let's do, this is called direct substitution, by the way, is this process. This is direct substitution. All right, where I directly replaced or substituted all of the x's with a negative 2. Let's do this using direct substitution and then see if we could figure out what would we do if we wanted to find our own shortcut. And see if we can prove our hypothesis. So let's see, equals, so 3 cubed, 27, plus 2 times 3 squared is 9, right? Minus 21 plus 1 equals, I know I'm writing fast, you guys will be able to catch up though. Don't you worry. Let's see, negative 21 plus 1 is the same as negative 20. So let's see, so I get 27, negative 20 is 7. Plus 18, I think 25 is my answer. So, I'll let you catch up before I ask any further questions. So that is direct substitution. How do you think I could have gotten 25 if I was doing a synthetic division problem? What would I have done? Does anyone have a theory? Right, because we got 15 for our remainder when I did synthetic division by negative 2, which is the same thing I got when I did P of negative 2. I also got 15. So what do you think I could do if I want to figure out P of 3? What's a synthetic division style way I could do that? What would I want to put in the box here, do you think? Yeah, right? So in this case, it is the 3 that I want, right? Because it's already kind of the opposite of what it would have been if it was synthetically divided. And what are my coefficients here that I'd be writing out? I know I don't have the polynomial written out, but you might be able to tell from here. 1, 2, negative 7, 1, right? No placeholders still. And what is our theory? What are you expecting to get from this? We're expecting the remainder to be 25. technically what I'm solving is I'm figuring out what is this polynomial divided by x minus 3 equal to. All right? But that's not what we're actually interested in. My goal for this problem, I'm kind of using a shortcut or an alternate method. My goal is I just want to figure out what p of 3 is. And I found out that, or our hypothesis is that the remainder of this synthetic division problem is going to be our answer. All right, so I just want to point out our answer is not going to be the polynomial we get. Our answer is the remainder that we're looking for. All right, so let's divide this synthetically. So bring down the 1. 3 times 1 is 3. 2 plus 3 is 5. 3 times 5 is 15. 15 and negative 7 is 8. And 3 and 8 is 24. Add those, I do in fact get my remainder of 25. So because of that, I would say, hey, I think p of 3 is equal to 25. Peculiar, huh? Not something I would have expected, all right? Like, it's, you know, a little bit unusual perhaps, but if I had done, we could spend, you know, all day doing dozens and dozens of problems and we'd find out that this works every time, which technically isn't a true mathematical proof of something, because what if I just happened to pick coincidences over and over and over again? Would it really work for infinitely many possible problems? But, I mean, it could be proven as well, but which is what mathematicians did, but I don't need us to do that right now. So, so this is called synthetic substitution. All right. And the basic idea is this. If I have some, so I've got some polynomial, and if I want to figure out what p of a is, that is going to equal to the remainder of my polynomial. Well, I guess I was going to write it as a fraction, but maybe we'll write it as my polynomial divided by x minus a. All right? If I want to think of it that way. Or I could think of it as the remainder of p of x synthetically divided by a. All right. So it's something, you know, a little bit of an unusual thing, but I want to point out this is helpful to us because it's faster than direct substitution. All right. So here's kind of two possible explanations of it there, I guess. Right? It's equal to both of those. I want to justify why it would be worth knowing this method. All right, so check this out. When I did direct substitution, all right, of p of 3, I had to know PEMDAS fully, right? I did exponents, right? I did exponents, I did multiplication, I did addition and subtraction, right? I had to use, well, I didn't do division there, but I used 4 separate operations in order to figure that out, all right? And I had to do it in the right order. But when I use synthetic substitution, notice the only 2 operations I do are add and multiply. Add and multiply. Which addition and multiplication, like those 2 things, are easier than having to figure out, is the sign of a negative raised to an even exponent, what's that? Like, I didn't have to worry about any of that. I didn't have to do any exponents the whole time, right? All I had to do, add, multiply, add, multiply, add, multiply. Right? I didn't have to use any parentheses. I didn't have to figure out PEMDAS. It's a much quicker process, at least mentally. All right? You know, arguably, I don't know. Well, no, I think I did write more symbols there as well. Some of that you could maybe do in your head a little bit more. But it's easier math to be done. And eventually, we'll actually even truncate that even more and shorten that down even further to like an easier way. So that's the idea of synthetic substitution. Instead of doing direct substitution, we'll just synthetically divide by what we're plugging in, and our remainder will be our answer. So P of 3 is equal to the remainder. Cool stuff, cool stuff. Let's see, one more thing I need to show you today. Let's see if my book wasn't blurry. That'd be good. So this is, there's a whole lot more here than what I just said about synthetic substitution. Let's see if I can get a good, clear shot. Bam. This is called the remainder theorem. It's technically what we're applying. The process we're doing is called synthetic substitution. Let's see, let me get a fresh sheet of paper there. And this is what it says. All right. So you don't have to write this down. This is found on page 485 of your text. And it's in this video if you wanted to reference it later if you didn't have your book. So the remainder theorem says this. So if a polynomial f of x is divided by x minus a, the remainder is the constant f of a. So that's kind of the truth that I just said about synthetic division. It's written in kind of, synthetic substitution. It's written in kind of the reverse order, right, where I said originally we were trying to find f of a, and then I told you what that's equal to. That's written the other way around. And then it has this kind of follow-up fact, which I find interesting, that the dividend is equal to the quotient times the divisor plus the remainder. And that's why I wanted to make sure we knew our vocab correctly. That makes more sense. So the dividend is my polynomial, the thing I was dividing. The quotient is the answer I got, right? The divisor is the thing I divided by. And then the remainder is, I could write that as f of a, now that I know that the remainder can be, right, just found that way, or just whatever I get as my answer. So I just want to, and let's see, I guess let's write it out. Or q of x is a polynomial with degree 1 less than the degree of f of x, which I think one of you had said that my answer from synthetic division, the degree of the exponent was 1 less, right, than the one before. So what I want to do is actually, let's steal this problem right here. Well, maybe I'll steal this one, because this has got all of our vocabulary written on it. That's good. So your screenshot can't be saved. Boo you, computer. Come on. I wonder if I'm like too far over. No, it doesn't like me. Why are you doing this to me? All right, here we go, for realsies. It worked, haha. So let's, I just want to verify that last fact for us, and then we'll call it a day. We'll do some partner work. And let's see, good, I'm all the way out of the way. So just to verify, because some of your homework tonight, they'll actually ask you to write your answer in that way. So let's write that out. So the dividend, all right, is this true? Is the dividend equal to the quotient times the divisor plus the remainder? So I'm just going to say dividend equal, and we could write out the whole thing, but so it's going to be the quotient, which is x squared minus 7, times the divisor, which is x plus 2, plus the remainder, which is 15. So let's verify that this works. So I'm expecting whatever I get when I multiply this out and combine like terms, I'm expecting it to equal that. So let's just verify that real quick. So how could I multiply these two binomials? Distribute, or someone said it earlier, that 4-letter acronym that they were referring to. FOIL is, this is when I could FOIL, right? But distribution is typically the stronger way to think about it, because it, distribution works every time. FOIL only works for a very special case, multiplying a binomial times a binomial. So let's see, so x squared times x is x cubed. x squared times 2 is plus 2x squared. Negative 7 times x is negative 7x, and negative 7 times 2 is negative 14, and then I've got plus 15 hanging out. Let's see, do I have any like terms I can combine?
Negative 14.
Yep, so those guys are friends for life. So I get x cubed plus 2x squared minus 7x plus 1. Is that what we had as our original dividend? It is what? What? So this actually does work out. I didn't rewrite the dividend there, so I kind of used this as a check. But so your book, just to establish that concept, might have you write your answers in this way. They'll probably write out the whole dividend, but I won't need you to do that. So kind of an interesting little relationship there, but it makes sense. I mean, because basically, well, actually, we even saw it classified right here, where I said, okay, x cubed divided by x is x squared, right? So I divided something, I get an answer, right? So here's my dividend, here's my divisor, here's my quotient, right? And then later, in the next step, I did quotient times the divisor, right? And I knew that it had to equal x cubed. I knew there was no other way around it because, right, if that divides to be x squared, then x squared times what I divided by should bring me back to the original. So that's kind of like the same concept displayed right there. All right, so synthetic substitution is the main skill that we gain from the remainder theorem. The fact that we can do that shortcut substitution, which is going to save us a lot of time, mucho tiempo, later.